Ever notice how your Subaru used to feel so much smoother when you first bought it? Maybe you're driving a 2016 RX that doesn't pull like it used to, or perhaps a 2019 Crosstrek that's mysteriously guzzling fuel. After spending 2 decades working on these horizontally opposed engines, I can tell you something that might surprise you. The vast majority of power loss and efficiency problems have nothing to do with worn-out internal components. Your Boxer engine is probably in better shape than you realize. What's killing your performance is a handful of maintenance tasks that almost nobody bothers with. I'm going to show you exactly how to restore your engine's responsiveness without dropping thousands at the dealership. These aren't band-aid solutions or magic additives. This is real maintenance that addresses the root causes of degraded performance. Stick around because the final technique I'm sharing can unlock horsepower you've been leaving on the table for years. Let's get started. The first area that demands your attention is the entire air intake pathway. If you could see inside your Subaru's intake tract right now, you'd probably be shocked. I've removed intake components from vehicles with just 70,000 miles that looked like someone poured molasses through them. This thick carbon coating dramatically restricts airflow to your cylinders. The horizontal layout of the Boxer engine actually makes this accumulation worse because the fuel spray pattern creates different deposit characteristics compared to traditional vertical engines. Here's how you tackle this systematically. Begin with your throttle body assembly. Disconnect the air intake duct and take a good look at the throttle plate. See that dark film coating everything? That's your problem. Get yourself some dedicated throttle body cleaning solution. I need to emphasize this because I've seen people grab whatever aerosol can they find in the garage. Brake cleaner will absolutely destroy the delicate coatings and rubber components in modern throttle bodies. Use the right product, spray it generously on the throttle plate, and use a soft brush or microfiber cloth to wipe away the deposits. You'll see the difference immediately as shiny metal appears where black crud used to be. Now turn your attention to the mass airflow sensor. This component sits in your intake stream and measures exactly how much air is entering the engine. Your engine computer uses this data to calculate the precise amount of fuel needed. When the sensor gets contaminated, it sends incorrect readings to the computer. The result is an engine that runs too rich or too lean, idles roughly, and wastes fuel. The fix is straightforward, but you must use the correct cleaner. Mass Airflow Sensor Cleaner is specifically formulated not to leave residue. Regular cleaners will make the problem worse. Remove the sensor from the intake tube. You'll see extremely delicate wire elements or film elements depending on your model. Spray the cleaner from about 6 inches away. Never make physical contact with these elements. Let the sensor air dry completely before reinstalling it. The intake manifold itself represents the biggest opportunity for improvement. This is where air gets distributed to each cylinder, and it's also where the worst carbon accumulation occurs. On most Subaru models, manifold removal is more accessible than you'd think. You're typically dealing with 8 to 10 bolts and various vacuum connections. Take photos with your phone as you disconnect things so reassembly is straightforward. Once the manifold is off, prepare to be disgusted. The intake runners are usually coated with a sticky carbon layer that can be several millimeters thick in severe cases. Fill a large container with industrial degreaser and submerge the entire manifold overnight. The next day, use brushes to scrub out the loosened deposits. Rinse everything thoroughly and let it dry completely before reinstallation. The improvement in throttle response after this procedure is immediately noticeable. For those willing to invest a bit more, walnut blasting the intake valves represents the ultimate carbon removal technique. Direct injection engines are particularly susceptible to valve deposits because fuel never washes across the valve surfaces. A specialized machine blasts crushed walnut shells at high velocity against the valve faces, removing every trace of carbon without damaging metal surfaces. This isn't a DIY job for most people. You're looking at spending between $300 and $600 depending on your location. I've performed this service on engines with over 150,000 miles and seen dramatic improvements in power delivery, fuel economy, and idle quality. If your Subaru has significant mileage and you've never addressed valve deposits, this investment pays for itself in restored performance. Moving on to the second critical system. Let's talk about crankcase ventilation. The positive crankcase ventilation system is absolutely vital to engine health, yet most owners don't think about it until something goes catastrophically wrong. This system removes blow-by gases from the crankcase and routes them back into the intake to be burned. When it's functioning correctly, it's invisible. When it fails, you'll experience excessive oil consumption, fouled spark plugs, rough running, and even potential seal damage from abnormal crankcase pressure. I've diagnosed countless cases where a clogged PCV valve created enough vacuum imbalance to pull oil past seals that were otherwise perfectly fine. You end up paying for a major seal replacement when the real culprit was a component that costs less than $20. The PCV valve itself should be replaced on a regular schedule. I recommend every 60,000 miles, regardless of whether you're experiencing symptoms. On most Subaru engines, you'll find it integrated into one of the valve covers. Access is usually simple. Pop off the cover, twist out the old valve, and install the new one. Takes longer to get your tools out than to actually do the job. While you're in there, inspect every rubber hose connected to the PCV system. These hoses endure constant exposure to oil vapors and heat cycles. They become brittle and develop cracks that create vacuum leaks. Even a tiny leak disrupts the engine's air-fuel mixture calculation and causes performance issues. Replace any hose that shows signs of hardening or cracking. Turbocharged models require additional attention. Check the turbo inlet hose very carefully. This is the hose connecting the turbo to the intercooler and intake system. Any leak here means you're losing boost pressure that your turbo worked hard to create. Even a small boost leak can reduce power output by 25% or more. You're building pressure that's escaping before it reaches the cylinders. Inspect all intercooler connections and charge pipes. These are under significant pressure and prone to developing leaks at clamps and connection points. Tighten everything down and replace any suspect components. Many Subaru models from 2010 onward include an oil-air separator as part of the crankcase ventilation design. This component helps separate oil particles from crankcase gases before they're routed back into the intake. It's an effective system when clean, but it accumulates sludge over time. A clogged separator creates the same problems as a failed PCV valve: excessive oil consumption, carbon deposits, and poor performance. Plan to service this component every 100,000 miles. Some are cleanable, others require replacement. Check your specific model's requirements. The third area demanding your attention is the complete fuel delivery system. Your engine's ability to generate power depends entirely on getting the right amount of fuel atomized properly and delivered at the correct pressure. I've removed fuel injectors from engines with just 90,000 miles that were so clogged they barely produced a spray pattern. Those engines were experiencing misfires, terrible fuel economy, and progressive carbon accumulation that made everything worse. Here's how you restore proper fuel system function. Start with regular use of quality fuel system cleaning additives. I'm not talking about miracle products that make ridiculous claims. I'm talking about proven detergent packages that actually clean deposits from injectors and combustion chambers. Products like Chevron Techron, Concentrate, or Lucas Fuel Treatment have demonstrated effectiveness in independent testing. Add a bottle to your tank every 5,000 miles. These cleaners work gradually to remove the varnish and carbon deposits that accumulate on injector tips and intake valves. They won't fix severely clogged injectors, but they absolutely help prevent deposits from forming in the first place. When you're dealing with an engine that already has significant fuel delivery problems, you need professional injector service. This means removing all injectors and sending them to a specialist for ultrasonic cleaning and flow testing. The process involves testing each injector's spray pattern and flow rate, then using ultrasonic vibration in a cleaning solution to remove internal deposits. Afterward, they're tested again to verify proper operation. This service typically runs between $150 and $300, depending on your area and how many injectors need service. I've seen this procedure completely eliminate misfires and restore smooth operation on engines that owners thought needed replacement. Don't overlook the fuel filter if your model has a serviceable one. Many newer Subarus have lifetime filters integrated into the fuel pump assembly, but older models have replaceable inline filters. If yours can be changed, do it every 60,000 miles. A restricted fuel filter creates fuel starvation under load. Your engine might run fine at idle and cruise, but fall flat when you try to accelerate. In severe cases, a clogged filter can actually damage your fuel pump by making it work harder to push fuel through the restriction. For the cost of a $30 filter and 20 minutes of your time, you eliminate this potential problem entirely. Fuel pressure is another aspect worth verifying. Your Subaru's fuel system operates at a specific pressure range. Too low and the injectors can't atomize fuel properly. Too high and you're running rich and wasting fuel. If you're experiencing performance issues, connect a fuel pressure gauge and verify you're getting the specified pressure at idle and under load. Low pressure usually indicates a failing fuel pump or clogged filter. High pressure typically means a faulty fuel pressure regulator. Either condition will prevent optimal performance, regardless of how clean everything else is. Now, let's address ignition system health, our fourth focus area. Your engine's ability to efficiently burn the air-fuel mixture depends entirely on proper ignition. Weak spark or mistimed ignition kills performance and fuel economy while increasing emissions. The good news is that restoring ignition system performance is relatively inexpensive and highly effective. Spark plugs are the foundation of ignition health. I'm constantly surprised by how many people drive around on spark plugs with twice the recommended mileage. Yes, modern plugs last longer than old designs, but they still wear out. The electrode gap increases as metal erodes away. This wider gap requires more voltage to jump, and eventually your ignition coil can't deliver enough energy. The result is weak spark, misfires, and incomplete combustion. Check your owner's manual for the recommended replacement interval. Most Subaru applications call for new plugs every 60,000 miles, though some longer life designs go to 100,000. Don't push these intervals. Spark plugs are cheap insurance against misfires and the catalytic converter damage that misfires can cause. When installing new plugs, pay careful attention to the gap specification. Even new plugs can arrive with incorrect gaps. Use a proper gap tool to verify and adjust as needed. And please don't over-tighten them. Spark plugs thread into aluminum cylinder heads. Over-tightening can strip the threads and create a nightmare repair situation. Tighten to the specified torque or just snug if you're doing it by feel. Ignition coils are another component that degrades over time. Modern coil on-plug designs put the coil directly on top of each spark plug. They're exposed to extreme heat cycles, and eventually the internal windings break down. A failing coil produces weak or inconsistent spark. You might have an intermittent misfire that comes and goes with temperature or load conditions. If you're experiencing misfires and the spark plugs look fine, test the coils. Many auto parts stores will test them for free. If one's bad, I generally recommend replacing all of them if the vehicle has high mileage. They've all experienced the same heat cycles and stress. If one failed, others aren't far behind. Spark plug wires on older models also deserve inspection. The insulation breaks down over time, allowing spark energy to escape before it reaches the plug. Look for cracks, burning, or discoloration. If the wires are original and you have over 100,000 miles, just replace them. You'll get more consistent spark delivery and eliminate a potential source of misfires. The fifth critical area is your engine's breathing on the exhaust side. Everyone focuses on intake flow, but restricted exhaust is equally damaging to performance. Your engine is essentially an air pump. It needs to expel exhaust gases efficiently to make room for the next intake charge. The catalytic converter is usually the first exhaust restriction point. These devices use precious metals to convert harmful emissions into less toxic compounds. Over time, the catalyst substrate can become clogged or damaged. A partially blocked converter creates back pressure that chokes the engine. Power drops significantly, and fuel economy suffers because the engine has to work harder to push exhaust out. Testing for a restricted converter is straightforward. Use a back pressure gauge threaded into an oxygen sensor port. Anything over 3 to 4 psi at 2000 RPM indicates restriction. You can also use an infrared thermometer to check cat temperature. The outlet should be hotter than the inlet if it's working properly. If the inlet is significantly hotter, the catalyst is likely clogged. Unfortunately, there's no real fix for a failed converter except replacement. Aftermarket options are much cheaper than dealer parts and work perfectly fine in most cases. The exhaust manifold and related gaskets also warrant inspection, especially on higher mileage vehicles. Exhaust leaks before the oxygen sensors will cause the engine computer to receive false lean readings. It compensates by adding more fuel, which kills your economy and can damage the catalyst with excess unburned fuel. Listen for ticking or hissing sounds from the engine bay, particularly when cold. That's often an exhaust manifold gasket leak. On some Subaru models, the exhaust manifold bolts actually stretch over time and allow leaks to develop. Replacing the gaskets and bolts solves the problem permanently. The final area I want to cover might seem basic, but it's shockingly neglected. Proper engine oil maintenance isn't just about changing oil at regular intervals. The type of oil, the filter quality, and even how you drive after an oil change all affect long-term engine health. Subaru Boxer engines have specific oil requirements because of their horizontal layout. Oil has to work against gravity to reach certain components. Using the correct viscosity is absolutely critical. Too thick, and you get poor cold start lubrication. Too thin, and you risk inadequate protection under high loads. Always use oil that meets Subaru's specifications. For most modern engines, that means 0 watts, 20 or 5 watts, 30 full synthetic. The synthetic base oil provides better protection across temperature extremes and resists breakdown better than conventional oil. Yes, it costs more. The extra expense is trivial compared to engine repairs. I've torn down engines that used cheap conventional oil their whole lives. The wear patterns and deposits are dramatically worse than engines that used quality synthetic. Change your oil every 6,000 miles or 6 months regardless of what the maintenance reminder says. If you drive in severe conditions, short trips, extreme temperatures, or dusty environments, cut that interval to 5,000 miles. The oil filter deserves attention too. Not all filters are created equal. Cheap filters use inferior filter media and bypass valves. Under certain conditions, they can allow contaminants to circulate through your engine. Stick with quality brands like OEM Subaru filters, Purelator, Wix, or Mobil 1. The few extra dollars buy you better filtration and more reliable bypass valve operation. When you change your oil, always let the engine drain thoroughly. Don't just crack the drain plug and immediately close it. Let it drain for at least 5 minutes so you get as much old oil out as possible. The less contaminated oil remaining in the system, the better your fresh oil can perform. Here's something most people never consider. How you drive immediately after an oil change matters. Fresh oil hasn't had time to circulate completely through all engine passages. Don't jump on the highway and run it hard right after service. Drive gently for the first 20 or 30 miles. Let the new oil work its way through the system and coat all surfaces properly. This is especially important on turbocharged engines where oil is critical. For turbo bearing lubrication, beyond these specific systems, develop a habit of listening to your engine. You drive your Subaru every day. You know what it normally sounds like. When something changes, investigate immediately. A new ticking sound could be a valve adjustment issue or an exhaust leak. A rougher idle might indicate a developing vacuum leak or failing ignition component. Catching problems early when they're small and cheap to fix prevents catastrophic failures that cost thousands. Keep a small notebook in your glove box and jot down anything unusual. Note the mileage, conditions, and exactly what you noticed. Patterns often emerge that help diagnosis tremendously. Regular inspection walks around your Subaru also pay dividends. Pop the hood once a week and look for obvious issues. Check fluid levels, look for new leaks or stains, verify belts aren't cracking, and make sure nothing looks out of place. This 5-minute habit catches problems before they leave you. Stranded. I can't count how many times a customer came in with a catastrophic cooling system failure that could have been prevented if they'd noticed the slow coolant leak that had been there for weeks. Everything I've shared today comes from real-world experience fixing these engines. The Subaru Boxer engine is fundamentally robust and long-lived. What kills them isn't design flaws or weak components. It's neglect of basic maintenance and ignoring systems that aren't obviously broken until they fail completely. You don't need expensive parts or dealer-level diagnostic equipment to keep your engine running like new. You need attention to detail, quality products, and consistent maintenance habits. Make these procedures part of your regular vehicle care, and your Subaru will reward you with hundreds of thousands of miles of reliable performance.